Hey you all, Farmer Jesse here. Welcome to the No-Till Market Garden Podcast, episode 21. Oh my, do we have a fun episode for you this week. I got a chance to chat with Dr. Elaine Ingham of Soil Foodweb Inc. about soil health, managing water quality, how she feels about Korean natural farming, which kind of blew my mind, and perennial cover crops. Yeah, we went for it. So I am excited to bring you this episode, but I could not do it without your support. I am giving away to 4 lucky patrons a copy of one of the best books I've read in recent years called Farming for the Long Haul by Michael Foley. It's from Chelsea Green. I will be doing regular giveaways like this, maybe with books, maybe with tools. To enter, you just have to be a Patreon member or have donated via Venmo or PayPal or given us a check. The number of entries you receive is relative to your yearly donation. So if you give $2 at Patreon, that's 24 entries. Cool, right? Visit patreon.com/farmerjesse for more details, or at Venmo, we are no-till growers. That's ampersand no-till growers. Also excited to say that today's episode of the podcast is brought to you by Paper Pot Co. Today we are talking soil with Dr. Elaine Ingham, and one of the great ways to build soil while minimizing the disturbance of soil layers is a broadfork. Broadforks open up tight soils by creating cracks for water and air to flow through. One problem with broadforks, though, are the handles. They break. Voice of experience here. Wooden handles typically can't withstand the pressure brought on by heavy soils or regular use. That problem has been solved by Meadow Creature. Creating broadforks made out of 100% steel, you don't have to ever worry about your broadfork breaking. A claim that's backed up by a lifetime guarantee, and also relatively by the fact that I've had my Meadow Creature for nearly a decade. It's available in 3 sizes and made in the USA. If you're going to buy a broadfork that will last you for life. Buy a Meadow Creature. Meadow Creature Broadforks are available at paperpot.co. Save $20 on a Meadow Creature Broadfork right now by entering the offer code SAVE20 at checkout. That's SAVE followed by the number 20, all one word, at paperpot.co. All right, enough from me. Let's dig into the soil food web with Dr. Elaine Ingham. Dr. Elaine Ingham, welcome to the podcast.
I'm glad to be here.
Great, and we're glad you are here. We're excited to have you on. Your work has been hugely influential to myself and so many of our listeners, but I thought we could start with you just kind of giving us a little rundown of Soil Foodweb Inc. and what you do there.
I am the president of Soil Foodweb Incorporated. I started the company back in 1996 when it was clear that the university and I were going to be going 2 different directions because the university was very supportive of genetically engineered organisms and, of course, the work that my graduate student Michael Holmes did, showing how dangerous genetically engineered organisms could be. So you can't take the attitude that the genetically engineered organism is of no greater risk than the parent, which is USDA regulatory law. And so that's absolutely false. And so kind of loggerheads with my university and some of the control that you get from the biotech companies. I could see the handwriting on the wall, so I started Soil Foodweb Incorporated to work more closely with growers and, of course, still continue the research work. It's a kind of a novel way to fund my research, basically, is to start a business that we help people grow plants without inorganic fertilizers and without pesticides, herbicides, any of those asides, which are the wrong approach to take. Mother Nature has those pest organisms for a reason. They are if we look at it from a human point of view, those pests are telling you there's something dreadfully wrong with your soil and you need to fix that. And if you don't pay attention to the gentle message that nature sends you, she's going to up the game a little bit and send worse pests or diseases. And if you don't pay attention to that, things are just going to keep getting worse and worse and worse, until the point where we're destroying water quality and we're destroying soil. We've just harmed the biology in the soil, and that's what turns it into dirt. So looking at all of those changes, helping to document those changes, and now how do you get those organisms back into the soil in the most efficient way, the least cost to the grower, get all of that biology reestablished so you don't have to work so hard. Yeah, the transition can be a little bit tough, so the first 2 to 3 months of conversion, fair amount of work might have to be done to get that biology back into the soil. But once it's there and you no longer do anything to kill it, you're pretty well set at having an easy go of raising the crops with all the nutrition in them that you require, that your animals require. So growing bigger and bigger all the time at Soil Foodweb. So that's kind of the brief overview.
Yeah, that's great. So maybe talking about that idea of dirt and things that hurt the soil, can we just kind of start with you giving us a sort of idea of what happens from a biological standpoint when you till soil?
The simplest explanation is that you're going to slice and dice and crush all of the organisms. Bacteria tend to be less affected because bacteria are so small that many of them survive that tillage process, kind of hidden in cracks and crevices on parts of the sand, silts, and clays, organic matter that didn't get crushed up against each other and squishing or crushing those organisms. Fungi don't survive tillage very well at all because fungi are strands, and fungi grow around things, pulling them together, and when we till, we rip apart that network holding the structure of the soil together. The bigger organisms are, of course, going to be extremely impacted. A lot of crushing and destruction occurring. You impose a compaction layer on your soil at whatever depth your tillage equipment goes to, because your tillage equipment has to rest against, pushes down on the soil at that depth, however deep your tines or your stanchions or your blades reach, it's going to cause compaction in that soil. So you're imposing the very thing you're trying to get rid of by doing the tillage. So we have to perhaps use tillage if you have really bad compaction layers, if there's really horrific layers where no oxygen can get through to those deeper levels, water can't move through to the deeper levels, things are going to start to go anaerobic, and it is those anaerobic conditions that select for the diseases and pests to be growing, surviving, reproducing in those compacted layers. Some of the most toxic things that kill plants are produced under those anaerobic conditions. So it's a source of this never-ending inhibitory substances that will volatilize and move up into the soil where your roots are growing and will have a negative impact on your roots. So we have to get rid of those compaction layers, and the only way to do that is to get biology back into the soil and rebuild structure. It is life that rebuilds the structure, and so we have to understand which sets of organisms are most important and the habitat that promotes their continued existence and reproduction, and make certain that we do nothing to select for the bad guys, the things that cause diseases and cause those toxic chemicals to be produced. So we may, for the last time, till your soil because we'll till in these inoculums of these really beneficial organisms. And we, of course, are not going to be using 1 or 2 species of bacteria because that's laughable as a solution to this problem. You've got to get the whole food web. You got to get the whole diversity of bacteria. 4 species of bacteria is just ridiculous when you think that you need on the order of 75,000 species of bacteria per teaspoon of your soil. In order to bring back that one particular group, you've got to get that amount of diversity. Well, fungi, same thing. 25,000 species of fungi typically in a gram of soil. So we have to make certain that we have the inoculum of this wildly diverse fungal community, and then we have to have the protozoa, and we also have to have the beneficial nematodes, not the bad guy nematodes. Then we need the microarthropods present in there. We need the spiders. We need the whole food web, all the way through to human beings, need to be reestablished in that soil so that we will be able to grow our plants without expensive inputs into that system. So do away with that inorganic fertilizer, do away with those pesticides, do away with any of the chemical treatments not needed if you get the biology back.
That's great. And you talked about creating an inoculum and possibly tilling it into the soil. Are there situations in which you wouldn't till it into the soil? Or are there additional ways that you insert that into compaction layers?
Yeah, there are additional ways because, of course, you're not going to till if you're trying to grow a perennial plant. If it's already in the system, now how do you deal with getting that biology back into the soil? And the most efficient way there is to do injections. It takes a while. In most instances, if we put a drench on the surface of the soil, maybe cover the surface with mulch to try to protect that soil surface, and we're even at the point where we're recommending permanent, perennial, low-growing cover plants, and we call them cover plants, not cover crops, because these aren't really crops, although you could grow strawberries, some of the short little strawberries, so that you could have an alternative crop. So with perennial plants, we can't be tilling. So the ways you get the biology into the soil is to inject down deep, where you're going to punch through those compaction layers and inoculate this complex food web that you need to support the growth, especially of perennials. Much more complex food web structure than when we're dealing with brassicas or cole or kale crops or even most grasses. So injection down deep, injecting that biology and in a liquid form. So we're going to make a compost and then extract those organisms using water and then inject those into the soil. Or we can use a soil drench. Soil drenches quite often can't get beyond any compaction layer. So if you have compaction in the upper inches of your soil, of your dirt, really, at that point. So if you've got that compaction layer, it's not going to be very effective to be putting on a soil drench and then crossing your fingers and hoping that that biology will be able to restructure your soil, rebuild the microaggregates and the macroaggregates. So if you know that you have no compaction layer, soil drenches work pretty well. We've seen situations where we apply a soil drench on the soil surface, and those organisms get down to 3 feet, 4 feet, and start breaking up the compaction layer at those deeper depths without us having to inject. It all depends on where are your compaction layers. And the way you measure compaction layers is to take a penetrometer, but you don't go out and measure compaction in your soil only when your soil profile is fully wetted up. You want to go out and be measuring compaction layers throughout the growing season, because rain is one of the most compacting factors. And when rain hits the surface of the soil, it depends on the pounds per square inch that is applying to the soil surface, where that compaction layer will form in your soil. And it could be 2 inches down or 4 inches down or 6 inches down. And so you need to be monitoring for that through the growing season. Because compaction can form at the, any time of year. And so you don't do penetrometer at just one time a year. You do it throughout the growing season so you can determine when you have a compaction layer starting to form. easiest way to prevent compaction layers from forming is to not be driving big, heavy equipment across your soil, not to have herds of animals going through and have them standing around for long periods of time in one small area, and then making certain that you always have an organic matter layer or a living mulch is what people often call it, where we have these low-growing perennial plants that cover the whole entire soil surface, so you get constant input of the foods, the exudates coming from the root systems of those low-growing plants to feed the biology in your soil and make certain that you have the same mycorrhizal fungi around the root systems of those cover plants as your crop plant requires. If you're growing brassicas, cole, kale, mustard crops, you want to make sure that you have cover plants that promote the actinobacteria that help prevent mycorrhizal colonization on the root systems of your brassicas, coles, kales, crops, and mustards.
Can you give us an example of some of those perennial cover crops? I'm really curious about these. I've heard you mention them before, and you just mentioned them now, and I'm curious about what kind of crops they are, and then also, like, are there a lot of commercial growers using them?
There are some commercial growers using them. We're still at the stage where we're trying to figure out exactly which of these species of low-growing perennial plants are going to work in different climates in different parts of the world. I have a long list of these short, low-growing cover plants that work here in Oregon because guess where most of the testing's been done? My yard. And so finding that information out. So if people are willing to trial some of the cover plants that we have listed, they were on the website. I think they're still up there. We've just recently undergone a major revision when we've moved away from the farm in California that we were working with. We were having troubles with them following directions, and so we need to work with people who will actually follow directions. So we are no longer working with ECI. We're starting a new company called Soil Foodweb School, and the website for the new school will be coming online really soon, but Soil Foodweb Incorporated, soilfoodweb.com, has just undergone a major revision, and I think the list of all of those cover plants are up on that website. If not, just give me a poke, and I'll try to make certain they get up as soon as possible. But so we're in that stage of still doing a lot of testing of different cover crops, which are cover plants that will be best in different regions of the United States and around the world.
And then when you're using, I love the potential of these perennial cover plants in terms of being able to just constantly be pumping carbon into the soil and feeding the bacteria and fungi, etc. And I would love to see. I'd love to see that develop.
Yeah, I'd like to have lots of people all over the world helping us figure this one out. It's take a small part of your property, even if it's in one bed or, a different cover plant in each bed to see which cover plants are going to give you the best result. So isotomas are a really good choice. The creeping thymes are another good choice that people have found. Dichondra, the temperate Dichondra repens, R-E-P-E-N-S, not the tropical Dichondra. The tropical Dichondra is a very weedy type of plant, drive you crazy. So make sure you get the right one. And there are seed sources for that at large quantities, so you could be doing that on a larger scale of an acre or maybe even as much as 10. And you only have to plant once. Once you get the perennial plant established, it survives through the winter. It regrows from its crown after, it's just like clover or Dutch white clover seems to work pretty well in most people's experiences when you're in fairly mesic systems in the really dry parts of the U.S. doesn't work all that well. But I can't recommend any of the mini clovers or micro clovers because it's not true that they only grow 1 or 2 inches or 3 inches tall. They will cover your brassicas very rapidly. So those are the kinds of things where we've got to test for and make certain that these plants work, because you don't want to be mowing them. You don't want to have to reseed them every year. You know, that's the problem with most cover crops. The USDA, the Extension Service, really focused on getting massive amounts of above ground plant material, because then you would mow it or burn it down, and that plant material would lie on the surface of the soil, and that was supposed to decompose and turn into soil. Well, if you've killed all your organisms in your soil by applying inorganic fertilizers, all of which are salts, and killed the biology in your soil, or pesticides, which amazingly there is no pesticide that kills just the target organism. It kills massive amounts more of your beneficial organisms in your soil and turns it into dirt. And so if you're expecting for the bacteria and fungi to decompose that cover crop material lying on the surface of the soil, think again. They're not there. And therefore, decomposition is not going to occur very rapidly at all, and you end up with anaerobic conditions starting to develop because no good aerobic organisms in that material to decompose it. Sooner or later, the bad guys will get going. So we have to, get people to understand that they really need to use plants where the root systems go down very, very deep and provide all of the biology in that soil as deep as possible, so that your crop plant roots have no obstruction, and your plant roots don't have to expend any energy at all in order to grow or push their way through the soil. So we want to go after cover plants that have root systems that go down maybe 10, 15, or 20 feet. The above ground part of the plant doesn't get any higher than 2 or 3 inches. So it's not going to get in your way. You're not going to have to mow it. You're not going to have to go out and mess with it. You just go out maybe once every 10 years and increase the diversity by overseeding once again. In the world of pasture production, working with Gabe Brown and Jay Fuhrer and Walter Lynn, that whole group in the northwestern prairies, so North and South Dakota, Nebraska, Kansas, in that area, Oklahoma, they have produced a mixture of fairly short, low-growing grasses that work very well, grasses, herbs, and forbs, that work very well at protecting the surface of the pasture at all times of the year, and whose roots grow very deep, thus helping your more productive pasture grasses, and helps the animals have a better mix of food resources. I don't understand why people say, put in a monoculture of this kind of grass because it grows the best under these conditions. There is no grass that grows the best under all of the different weather conditions you're going to experience going through the year. So you really need a diversity of these different plants. But it's the same idea, the work that Gabe has come up with and has been showing for the last, 25 years, that this works really well. Well, now we need to transfer it into this kind of knowledge, needs to be transferred into our crop production systems. It doesn't work just in grasslands. It's working in crop production. We just have to do the testing. We've got to get the data. Conditions here in Arizona or Louisiana or Virginia or Minnesota or Oregon. So we've got a little bit of testing, and we would love to have people help us with that. Let us know what you've tried to plant and how successful you were at that.
Yeah, that's great. I'm curious at how many people, seed breeders and those sorts of people are working on that problem, because it seems like there is a lot of potential. I mean, especially in your bigger crops, your corn and.
Yeah, we've only gotten a few companies kind of responding to this need. So, yeah, we need to do a little more advertising. Hopefully, as the Soil Food Web School gets going, we can have a group of people form a coalition that will monitor and go out to all of those seed companies and say, hey, there's a market for this. We're building that market. Can we please get some help from the seed companies? So that's a really good point. Thank you for saying that.
Hey, you all, just going to jump in here real quick and get a word from our amazing sponsors like Growing for Market magazine. For 28 years, Growing for Market has been the source for direct food and flower growers. All GFM content is custom written for the magazine by farmers like myself and others who get their hands dirty and know what they're doing. They do not recycle content that you've seen elsewhere. It is a consistently good magazine. If you do farmers market, CSA, farm stand, pick your own florist sales, or wholesaling, your business is different from any other kind of farming. Whether you're a commercial grower or just want to grow like one, subscribe to GFM for the nitty-gritty of growing, marketing, and the business of small farming 10 times a year. Available as a paper magazine, digital download, or both. Subscribe to GFM for the latest on market farming. There's information on growing vegetables and flowers in every magazine. And I will add, lots of good no-till articles. Use the coupon code NOTILL to get 20% off any subscription through growingformarket.com or call 800-307-8949. Subscribers always get 20% off the carefully curated selection of market farming books GFM carries, including podcast guest and GFM editor Andrew Mefford's brand new book, The Organic No-Till Farming Revolution, where Mefford interviews 17 different growers using no-till and gives an overview of the techniques, providing a roadmap for anyone interested in starting a no-till farm or converting an existing one to no or less tillage. That's growingformarket.com. Offer code NOTILL, lowercase, no hyphen. This show is also generously supported by Banner Greenhouses. Banner is a family-owned certified organic flower and vegetable plant producer. This second-generation farm has been producing plant starts since 1991, and they are extremely good at it. In fact, this is a sponsor that my partner in NoTillGrowers.com, Jackson, and I specifically sought out because of how much we love their product and know you will too. I have some Banner transplants in my garden as I speak. Their greenhouses and outdoor growing area cover 18 acres and enable them to provide optimum growing conditions for each cultivar. Get CCOF certified organic vegetable and flower transplants delivered straight to your farm. It's as simple as creating an account, choosing a crop and a desired plug size, then designating what week you want them to arrive. Whether you want to simplify your transplant production or don't yet have a prop house, get a better start with Banner Greenhouses.
Maybe I want to change gears here just a little bit, and something I've heard you sort of bring up a little bit but not really get in depth on is the impact of water quality and on plants and biology. Can you talk a little bit about that?
Sure. A complex subject. Water that's in our rivers and lakes and streams and the groundwater should be clean. It should have gone through the filtering system called soil. When toxic chemicals move through soil that has the right biology present in it, that biology has the capability of complexing those toxic chemicals, pulling the high nutrient contents out of that water. Dirt, where we've killed the biology off through this constant tillage, through the use of these toxic chemicals, the use of the inorganic fertilizer salts, this biology is gone. We need to have that biology back in the soil. How do you know it's there? Microscope. You have to monitor for it. You can't just hope. You can't just cross your fingers. And it's like in the organic world. Often when I go out to talk to organic growers, they say, I'm organic. I've been, certified. It took 3 years to get my certification, so I must have all the right biology in my soil. And the answer to that is no, you don't. If you really want to be successful at organic farming, you have to get the biology back into the soil, because you want to have these organisms present to take all those toxic materials out of that water, decompose that material, and turn it into more bacteria and fungi. You need to have the values of those, the biomass in the soil up to certain levels, given the kinds of toxic materials. Paul Stamets, for example, his company up in Washington State is doing a massive amount of work on exactly which species of fungus do you need to decompose this next nasty toxic pesticide or inorganic fertilizer or condensed organic matter that occurs when you get all this mass of different pesticides and inorganic fertilizers mixing together in your irrigation water. And oh my God, that stuff is just scary. I wouldn't even want to walk in irrigation water, much less put it on my crops, because the chemical load is usually just beyond what you even want to think about. So we have to clean up that water. When that water is coming onto your property and you're getting the irrigation, because it's the only source of water, you need to clean it up. And the easiest way to do that is make certain that you have a weir.
Okay, so unfortunately it clips out here for a second for some reason. So I'm not sure exactly the type of weir that she's describing, but I will try to find that out and put it in the show notes. Weirs are those dams that look sort of like they're not really working and the water pours over the top of them. I'm not sure exactly how that fits into what she's about to say, but gives you a general idea. Apologies for that. I am slowly improving the equipment for this podcast. By season 10, we'll be jamming. Anyway, back to Dr. Ingham.
Compost bag or net on the weir, so that as the water comes over the weir, it has to go through the compost, and all those organisms in the compost will very happily grab all of those toxic chemicals. They will pull them in, decompose them, convert them into organic matter that is going to be beneficial. But you have to have the biology to do that. If you just run your water through dirt, all it's going to happen is it'll make the problem worse, because you have no biology to do the job to clean things up. So if we can get that biology back into our dirt, convert our dirt back into soil, then that means anything coming out of your land is going to be clean water, either the surface water moving off, no more erosion, no more runoff of your nutrients from your land, because if you have biology in the soil, it builds structure, and your water infiltrates and is held in that soil. When we've worked in Australia or the southwestern part of the United States or Southern California, even on the east side of the Rockies here in Oregon and Washington, we can reduce water use in those systems by as much as 70% reduction, which means either your water bill is going to go way down, or you're going to be able to grow more crop because you've got the water to grow more crop. So we have to get this water holding capacity back into the soil. And you can get a little bit of water holding capacity just by mixing organic matter into the soil. But to really build the structure that will allow that organic matter to be able to fully uptake its water holding capacity, you have to build structure in the soil so the water gets to that organic matter and can absorb it and hold it in that water, in that soil. We have to build lakes. We've got to build, large holding vessels in the soil called large empty voids in the soil that will fill up partway with water. And so in that dry summer period, your roots will still be able to go down deeper and deeper and deeper into your soil and access that water that's been held from snowmelt or held from those spring rains. In California, you get rains only for a short period of time in the springtime, and you have to hold on to every bit of that water. You have to hold on to every bit of the dewfall that is happening, even in the driest of climates. When it happens, all of that water has to infiltrate into the soil, not evaporate, not wash off and form erosion problems, because that water can't infiltrate because you've got a compaction layer. So really critical for water quality to rebuild the structure within the soil, hold the water in the soil where it belongs, and make certain that whatever does come out of the soil into your groundwater, surface waters, lakes and rivers and streams, not going to cause a problem. There's the short summary of that.
What about using county water and city water in terms of irrigation?
You have to realize that in any water that goes through a municipality, by law, has to put materials into that water to prevent growth of pathogens, pests, the bad guy bacteria, the biofilms on the pipes that carry that water to your house, to your property. And so you're usually getting some pretty toxic chemical coming through in that water to prevent the growth of bad organisms. So they typically put in, they used to put in just chlorine, but we can no longer prevent the growth of those organisms, the biofilms with the bad bacteria growing in them, on the surfaces of the pipes, because so many of those disease-causing bacteria have become resistant to chlorine. They're not killed by chlorine anymore. And so we are starting, I think every municipality in the United States now adds chloramine into the water to kill the biofilm on the pipes, and that's a much more toxic chemical. If you use that chloraminated water on your soil, it's going to kill the biology in your soil. So you can monitor that. You can get really good compost and look at the compost, see all the organisms in that really good compost, and then apply that water, that chloramined water, and you can see how much of biology has died after just a couple hours of application of that toxic water. So when you think about human digestive systems, we have to have a whole lot of really beneficial organisms in our digestive system in order for things to work properly. Well, if you're drinking water that has chlorine and chloramine in it, you're going to be killing that biology. So your digestive system doesn't work right anymore. You have to re-inoculate all these really beneficial organisms back into your digestive system. That waterworks needs to be replenished with that biology. And the place you get that biology is from plants that were growing in really healthy soil. And all these really beneficial organisms got on the surfaces of the fruits and vegetables that you're eating, so that you're going to replenish that really beneficial biology. People who drink kombucha or, any one of the fermented drinks with lots of lactobacillus and lots of these organisms, anaerobic organisms in it. Okay, that can help, that can be part of the solution, but you're not getting everything that you need. So let's make certain that we're eating that organically grown food that had really beneficial biology in the soil, so you're getting that good set of organisms reestablished in your digestive system.
Yeah, that's great. It's a daunting thing to think about the amount of chemicals in our water and what it is doing to our guts and our plants. But
to our soils, to our digestive systems, and then people always ask me, okay, so what do we do? In the case of chlorine and chloramine, it's a pretty easy process. You just want to add enough humic acid, or really any organic acid, to that water to complex the chlorine and the chloramine. Typically, you have to add enough humic acid so that you can see the color shift. Humic acid is a nice, rich, dark brown color. So if you add a couple drops and you get rid of the chlorine and the chloramine, you'll see a color shift. Your water will get just a tinge of tan color to it. And as long as you can see that color shift, you know you've dealt with the chlorine and the chloramine. So that's the easy way to get rid of that particular toxic chemical in your water without killing any of your biology. And then you can use that water to water your compost pile or water your lawn or water whatever you need. There are hose-end applicators that you can get for dispersing 1 drop per gallon of water. So 1 drop of the humic acid solution into a gallon of the water is usually the ratio to overcome a normal chlorine-chloramine concentration. So that's easily taken care of. And then if you have other irrigation system problems where you know that water is toxic, that's where you want to be running that water through compost. Some people, have big sieves that they fill with compost, and then they run the water from the irrigation system through that large sieve. You probably have several weeks worth of ability of that biology in the compost, in that sieve, in that container where you're running that bad water through it. You've got a couple weeks worth of neutralization, decomposition, taking care of all of the problems coming through. But you're going to eventually have to change that compost if you have lots of toxic chemicals in that water, because that water is killing the biology slowly but surely in that compost, and thus you have to change the compost and replenish the beneficial life. You then take that spent compost and you recompost it again. You run it through the whole composting process over, which allows all of those organisms to be reestablished in that good organic matter. All those toxics will be taken care of, put into the structure of the organic matter. Even heavy metals are dealt with. So how do you know that you still have these organisms there? Microscope. Take a look and see massive numbers of all of these organisms in your compost or your soil, so you know they're taking care of these problems for you.
Yeah, that's great. It's nice to hear there is some amount of solution. Are people using, or would you recommend, this sort of fertigation system for that getting that humic acid into the water line? Or okay,
you can use irrigation systems. I'd always like to take care of the problem before you run it through your irrigation system. But if you have to be adding the humic acid to the water just before you run it into the irrigation lines. If you're wanting to put biology out through your irrigation lines, so you take a compost and you extract the organisms into the water, and then you run that through your irrigation line, just make absolute sure that you have neutralized the problem compounds in that water before you add it to the biology that you want to inoculate.
So let's change subjects just a little bit. I want to talk about Korean natural farming with you because I have some questions about it, and I'm wondering if you can kind of give us an idea of from a biological standpoint, how you feel about, the indigenous microorganisms captured through KNF, and any other thoughts you have in that vein.
Yeah, over in Korea, over in Southeast Asia, they grow a lot of rice. And so it's appropriate, I think, in that part of the world to take rice and throw it out into a forest or throw it out into a natural area and get some really good biology growing on that food resource, because that food resource is indigenous. Still, I look at what is rice really. It's a very simple compound. It is not something that's really going to encourage the best fungi to grow into that ball of rice. And so I worry a lot that they are not getting the really beneficial organisms growing in that rice. And now they bring that back in and put those rice balls into their compost or put it out into their property. They're not getting the most beneficial guys growing in that relatively simple substrate. It's not a very complex material. Now you come over here to the U.S. and you go throw a rice ball out into any one of our old growth or undisturbed habitats to try to grow, get an inoculum of these really beneficial organisms to grow on the rice, and that's just sorry. There's never been rice growing in any of our ecosystems in the United States, except for maybe along some of the coastlines. And so you're not going to be picking up the beneficial organisms when you throw rice out into your natural systems here in the U.S. Pick a different food resource. Rice in Korea, fine. That might make a lot of sense, although I'd still like to have them do some testing to make sure that they're really getting the most beneficial fungi. Here in the U.S., you want to be thinking about putting together wood chip balls where you're getting some natural glues or something that is going to select for the really beneficial fungi and not the not so good fungi, the disease causers perhaps. Then when I look at some of the other practices in Korean natural farming, they're making anaerobic teas. And they need to understand that maybe that anaerobic tea is a good herbicide. Maybe it's a good pesticide. But that is not the approach that we want to be using. We want to set up the habitat to be the one that selects, make sure it is those are the conditions that select for the beneficials. If you're going out and killing the disease causers by applying an anaerobic tea that's got lots of toxic chemicals in it, and that's what's doing the killing, you're also killing all your good guys at the same time. So you're kind of going one step forward and three backwards. And ultimately, you're not going to be able to reach the goal that you want to reach of having a habitat that selects for, promotes, and maintains these really beneficial sets of organisms. When you produce something that goes anaerobic, those anaerobic organisms are going to be taking your nitrogen and blowing it off as ammonia. That means there is no nitrogen left in that anaerobic brew. So you apply that out onto your soil, you're not getting some of the benefit that you want. You're not putting back in the nutrients that you might like to be putting back. Your phosphorus is going to be blown off as phosphine gas. Your sulfur is going to be blown off as hydrogen sulfide. You're producing some of the most toxic chemicals on the planet that will kill your plants. So not the right thing to be putting onto your agricultural soils. Of course, the response from people who make these materials is usually then, well, yeah, but we can drink it. It's good for you when you drink it. And I'll agree, yes, drink it. Drink the bokashi or the kimchi or the, whatever version of anaerobic tea that you're producing. Go ahead and drink it because your digestive system has anaerobic portions to it, and you're re-inoculating those good organisms for that part of your digestive system. Just don't forget the aerobic part of your digestive system. You need to also be inoculating those guys with what you eat. So, a lot of the practices for getting this biology into the soil, perfectly reasonable when you're using some of the teas and such, but make sure that these are aerobic teas, not anaerobic, because soil is a different thing from your digestive system, and you need to recognize those differences if you want to get the best results as rapidly as possible.
Interesting. That's an interesting point about the difference between human biology and soil biology. And also, I'm wondering, do you see potential in the idea of capturing, these indigenous microorganisms that are well established in the area by going out into the old growth forests? Is there any way that you recommend somebody? Do you endorse that idea, or do you have any ways of doing it that you would promote more?
Yeah, and because we've got large acreage, and even if you've only got an acre or 5 or 10, it's still going to require a significant inoculum to be put out there. And so you're going to be making compost. You can put out compost at about a ton per acre. So you got 5 acres, you're going to make 5 different piles, and through the course of the year, so you don't have to make it all at once. But you do want to go out into those portions of the ecosystem of your watershed and try to get small quantities. You only have to be taking a teaspoon, a couple grams. You don't need to be bringing back, 50 pounds, because if you bring back 50 pounds from an old growth forest or a very healthy and productive pasture or grassland meadow, you're destroying that ecosystem. So you're having negative impacts. You don't need that much. It's a teaspoon. And so when you're going out collecting, go out with a little sealable plastic baggie, and you pop the plastic baggie open and you put that teaspoon into your bag. And then you go back and you put that inoculum into the starting point of a composting pile. So when you start the compost, you want to be putting these inocula into your compost pile at that time, because you don't know whether or not there might be disease-causing organisms in that inoculum. Old growth forests do harbor some diseases. Those diseases can't become a plague. They don't escape the natural controls that are in that old growth forest or in that highly productive meadow. But you take those organisms and you put them into an anaerobic brew. Those are the conditions where now the disease-causing organisms are going to grow better than anything else. And so not the thing that we want to be doing, because there might be some diseases that you don't know about that have been suppressed by that old growth forest and the organisms in that forest or meadow for centuries. But now you've put them into a habitat that allows them to win in competition. So instead, put that material into your compost pile and make sure that you compost in a way that keeps that composting pile of organic matter aerobic. So you grow the beneficial organisms, not the bad guys. Make certain that you're monitoring temperature. We have a whole class. We have about 12 lectures. We've just recently revamped all of the online lectures, because we've learned so much in the last 10 years that it was time to update those classes and make certain that we have the latest and the greatest information that we're sharing with people when you take those online classes. So come take that compost class. Do you want a thermal compost? Do you want to make vermicompost? Or do you want to do static composting? You're going to achieve the same end with whatever method you're using. But in order to get to that positive end, you've got to understand what you're doing and why you're doing it. Because that's when mistakes are made. That's when people mess up and then, they produce really frightening, putrid organic matter, and they put it on their plants and it kills the plants. That's not the goal of this. You do have to know what you're doing. We're doing a number of other courses now. We have something called the Mastermind classes. We are going to be offering a Market Farm Mastermind class where we take 10 people at a time, and we basically hold their hands through the process of converting their dirt back into soil. It helps a lot if they have a microscope and they know how to use it. Otherwise, they have to be sending their samples into the closest lab, and we have lots of labs now in the United States and in places around. So people they'll be close enough to a lab that they could send it in to the lab for the analysis, but it's for the price of a microscope and somebody getting trained on it. You save a lot of money very rapidly by having that ability within their own farms. So in that mastermind class, we take people step by step through this process of conversion of dirt back into soil, and it's very hands-on. We expect people to be doing the work during the 6-week course, or actually it is a 12-week course, sorry. So through that 12-week course, we teach them how to do these conversions. We teach them about compost. If they really don't know how to make compost, then we expect that they're going to take the online class. If they really don't know how to use a microscope, we've got a class for that as well. So trying to get everybody revved up and as inexpensively as possible, using the equipment that they already have instead of going out and buying massive amounts of equipment more, so that they can convert their dirt back into soil. So we've got those classes. We have some classes on how to become a consultant, what's the business information that you have to set up a successful business doing these sorts of things, consultant or a laboratory doing samples for other people. And we have lots of opportunities for people who would like to travel to other countries and for 6 to 9 months set up these operations in other parts of the world under the auspices of people who have been out there doing this for the last 10 to 15 years and been highly successful in almost any system that you want to talk about. So lots of job opportunities.
Oh, that's good. Yeah, that's great to hear. And all that can be found at soilfoodweb.com.
Right, or hopefully within the next week or so, soilfoodweb.school.
Well, Dr. Elaine Ingham, this has been absolutely a pleasure.
It's I always enjoyed being able to help people understand what they need to be doing to get the best results out of their soil and convert their dirt back into soil.
All right, if you enjoyed that podcast, make sure to check out soilfoodweb.com. You can learn about all the different classes and courses and etc. that they offer. There are lots of great videos of Dr. Ingham on YouTube, and we put a bunch of them together at notillgrowers.com for you to peek at. Just hit up the search engine on that site. Please consider signing up for the Patreon page. We are working to get that up to $1,000 a month to be able to afford a second season of this podcast. That's patreon.com/farmerjesse. As I said at the beginning of this episode, this month I'm giving away 4 copies of the book Farming for the Long Haul by Michael Foley. It is wonderful. Next month it may be a tool. Just a little incentive. Also, make sure to support our show sponsors, Banner Greenhouses, Growing for Market, and Paper Pot Co. Also, don't forget that you can still get 10% off the Never Sink Flame and the Mutineer and its accessories through March 27th, 2019 over at neversinkTools.com. Also, please don't forget to subscribe to this podcast, leave a review on iTunes, share it at your favorite Facebook group, all that good stuff. Other than that, you all, thank you for listening. We'll see you next week. Bye.
Well, I thank you for allowing me to have the time to hold forth about this kind of information. It's really important to get it out to the general public.
I think you were getting it to exactly the right people in this podcast, too. We have solidly 1,000 listeners, and they are all seemingly very nerdy and into soil biology. So